Hello, Algebra 1 students. This video is going to be for section 7.1, so you're going to start in your chapter 7 new note packet. This 7.1 introduction that is on page 4, we're going to skip. This is just going to be the notes. However, you should definitely do that 7.1 introduction. It's likely that you will be doing that in class. I'm going to zoom in a little bit here. Okay, so we are on page 5 in your note packet. This ideally, part 1 or task 1, task 2, task 3 should be done by you. What I would like you to do is to pause the video and try task 1, task 2, and task 3. And then come back and we'll discuss it slightly. Okay, so hopefully you tried task 1, task 2, and task 3. So it's a little bit of an exploration of some of the things we're going to be looking at in section 7.1. So the first one said, which of the images below, which do you think don't belong, right? Then explain your thinking. So you might have various answers here. I don't want you to cross off what you had. I want you to check and see what you had and see if it's similar to what I have. The one thing that I noticed is that this one right here has an x to the second power. So remember, this is called an exponent. So I would like you to add that to your notes, and remember, if you need to pause the video, do that. Make sure you're writing and listening to everything I say. So this one has an x to the second power. This one has an x to the first power. There's always an exponent. Sometimes it's an invisible exponent. This one has an x to the first power. This one has an x to the first power. So that is one thing I noticed. Now some of you might have said, this one has 3 terms. Remember, terms are the things separated by pluses and minuses. This one would have 2 terms. This one would have 1 term. This one would have 2 terms. So if you have pluses and minuses between, then those are terms. So you might have noticed that. I said, I think x squared plus 5x plus 6 does not belong because x squared has an exponent of 2. And all the rest of them had an exponent of 1. This binomial and monomial and polynomial and binomial, this one is a binomial, this one is a monomial, this one is a binomial, this one is a polynomial. That's part of the new vocab you're going to be learning in section 7.1. Okay, task 2 said compare the examples of the polynomials and not polynomials. What can you say about not polynomials? So the first thing, hopefully, and again yours might be in a different order, is you might have noticed that this would be not a polynomial if your expression has something like that. And then I'm going to include this on that same line. So if you have that in your expression, that would not be a polynomial. You'll notice none of these have an exponent. They have exponents that are whole numbers, but they don't have exponents that are fractions. And there are no square roots in the polynomial examples. This would also be not a polynomial, what you see in this first part. This exponent, it is an exponent because it's, a small and up high, but it's not a number, it's a variable. So the polynomials have exponents. They're actually very common, but they are always numbers. Remember, pause the video, make sure you're getting this in your notes. No variable in the denominator. See these right here? The bottom of the fraction is the denominator, and we would say no variable in denominator. Denominator. So if you look over here, this is okay. A fraction with a number 2 in the denominator, that's okay. That's a polynomial. A variable, which means a letter, in the denominator means it's not a polynomial. And then I'd like you to add a number 4, which would be this, x to the negative 5, no negative exponents. Okay, again, if you need to pause the video to fill in the notes, that is totally fine. That's what you should be doing. Really, the best way to learn from a video is to watch and listen and then pause the video and then fill in your notes. It's difficult to write and watch and listen all at once. So I recommend you watch what I'm doing, listen to what I'm saying, and then pause the video and fill in your notes. Task 3 says, what is the degree of the polynomial? So here's some polynomials. Here are the degrees. It says use the table to find the degree of a polynomial. How can you find? You can find the degree by looking at or looking for the biggest exponent. Now this, I'm going to get a pen here so you can see it better. This polynomial has a variable. That variable has an exponent. It's the invisible 1. So this, the biggest exponent, notice not the numbers, the biggest exponent is 1. That's my degree. This has an exponent of 2. It also has an exponent of 1. But the biggest exponent is a 2. So we say this whole polynomial has a degree of 2. This one has the biggest exponent is 3, so we say the whole polynomial has a degree of 3. This one, you might be thinking, well, it doesn't have a variable. Up here, these exponents are always on the variable. Actually, let's add that in here. The biggest exponent on the variable, which most of the time will be an x. I want you to add in x to the 0 here. Now, anything to the 0 power equals 1. So 5 times x to the 0 is the same as 5 times 1, which is 5. But if you don't see an x, we say the degree is 0. So please add those to your note packet. Pause the video and add those. Okay, let's keep going with some more vocab. Again, we're talking about polynomials. So I'm just going to write an example of a random polynomial up here, like 3x to the 3rd minus 2x plus 6. That is a polynomial. They are functions. You remember back in chapter 3 we learned about functions and we said each input has a unique output, or we said x's don't repeat. So polynomials are functions, just like we've been learning about. In chapter 3 and 4, we did a lot of linear equations. That is also a polynomial. The lines that we've been drawing in chapters 3 and 4 are polynomials. So again, that's just a little extra information on polynomials. Please add that to your notes. Okay, now we classify them in lots of different ways. The first way we classify them is by how many terms they have. So we say a monomial has 1 term. An example of that could simply be a 3x. So this would be nothing added or subtracted to it. Nothing added or subtracted. Just 1 term. Another example could just be a number. Okay, binomials, I want you to think of a bicycle. Bicycle, which I'm spelling wrong. Bicycles have 2 wheels, so this would have 2 terms, added or subtracted together. So if you have an addition or subtraction The terms, this is the first term, this is the second term. Anything with separated by an addition or a subtraction. So there's one example. Could also just look like this, x plus 3. There's my addition, that's a term, that's a term. So two terms would be a binomial, and a tri, which means 3, would have 3 terms. So I don't know, that this one that I wrote up here at the top of the page is a trinomial, 1, 2, 3. I'll write a different one here. So if you look, I have pluses and minuses, and what's separated by those pluses and minuses? 3 terms, just like it says here, 3 terms. So we identify polynomials by the number of terms they have, and we also talk about classifying a polynomial. And when we say that, we're doing a lot of things. We're saying if it's a monomial, a binomial, or a trinomial. We're finding the degree, and we're finding the leading coefficient. So the new one that you haven't learned yet is the leading coefficient. But those are all ways that we classify a polynomial. It's kind of like identifying it. Sort of like, for a person it might be you say their name, you say their age, you maybe say what school they go to if you're classifying, say, a person of your age. So the degree, we talked about that, is one way that we classify a polynomial, and to determine the degree, we find the biggest exponent. Right, so like x to the third, that would be your exponents. The coefficient of the term in the front. Okay, I'm just going to leave that for now. We're going to talk more about this in a minute, but let's just put a little example and remind ourselves this is the coefficient. So that is a coefficient, the number multiplied by the variable. Now, to write a polynomial in standard form. Now, before we classify polynomials, we want to make sure they are in standard form. So this says rearrange the terms so that the highest or biggest exponent, so not numbers, we're looking at exponents, is first, and then the next highest, and so on. So here is an example. If you look at this polynomial, this has the biggest exponent right here of a 3. That always wants to be the term in front. I call it the line leader. And then the next biggest exponent is a 2, and then a 1, and this one has a degree of 0, or the plain old number hanging off the end. So the degree of this exponent would be a 3, because that's the biggest variable. That's the biggest exponent. The number hanging off the end we call a constant because it doesn't vary. It has a constant value. Once you're in standard form, that first coefficient that you come to, we call the leading coefficient. So the coefficient is what's multiplied by the x, and the leading coefficient will go with the x that has the biggest exponent. So here's kind of a way to think about when you put it in standard form. This is biggest exponent first, then next biggest exponent, then next biggest. This would have an exponent of 1, and this would be a constant, or plain old number. So if I look at this one, it says classify, so that would be monomial, binomial, trinomial. Anything bigger than a trinomial, we just call a polynomial. I forgot to mention that at the top, but we'll look at that in some examples. We want to find the leading coefficient. We're not going to do this right away. We're first going to write it in standard form. Then the leading coefficient will be right in front. The degree, again, is going to be biggest exponent. Biggest exponent, I'm going to abbreviate that. And standard form, we're going to do this first. We should have put that at the top. So we're going to write this in standard form first. You want to look at these exponents. 4, 3, 6. This is the biggest exponent. So this 10x to the 6 is going to become the line leader. So that's going to go first. That is going to be the first term in our polynomial. So we're going to put the 10x to the 6 right in front. Becomes like the engine on the train, goes in front. The next biggest exponent is this 4. So we're going to put this 3x to the 4th second. The 3 is positive, so we're going to write plus 3x to the 4th. The next biggest exponent is a 3, so we're going to put this term last. Now this negative is part of this term, so negative 5x to the 3rd comes last. So now it's in standard form. 6, 4, 3. Our exponents, not our numbers, our exponents are in order from biggest to smallest. Okay, now I'm going to go back and classify this. This has 3 terms. Remember, terms are separated by pluses or minuses. So this would be a trinomial. Remember, a tricycle has 3 wheels. A trinomial has 3 terms. Leading coefficient. Now that I'm in standard form, I find the first number right in front. That is my leading coefficient, is 10. Degree is the highest exponent. Remember, we said to find the degree, you find the highest exponent. Well, once you're in standard form, the biggest exponent is right in front, and that is 6. So when you're in standard form, your degree and leading coefficient are in front. They're the first things you come to. The coefficient is the number multiplied by the x, so 10 is the leading coefficient. The degree is the exponent. Once you get it in standard form, the degree and leading coefficient will be right in front. That's why we put it in standard form first. Okay, let's turn. And then you are going to try these. So I recommend that you pause the video and practice these. And then check them. If you get them wrong, awesome. That's how we learn, practicing. Just fix them. Okay, so hopefully you did the 3 your turns. I'm going to put this up quickly for you to check your answers. If you need more time to check your answers, just remember you can always pause the video. Okay, I will do the rest of 7-1 in another video.